Whenever you're given different data, one of the precursor steps that you need to take is understanding the different data structures available to you. Today, we're going to talk about 3 different data structures, the first being time series, the second being cross-sectional, and the third being panel data. The first type of data that we're going to look at is going to be time series data. Now, what is time series data? This is going to be a single or multiple observations over an interval of time. So that could be one person, we can name him Bob, over, let's say, 4 o'clock, 6 o'clock, and 8 o'clock. Now, another example or something that you might get in your data, right, would be something like GDP data or stock prices. Essentially, you're trying to forecast or find trends over cycles, right? One of the key features to note for this would be that time is very important. This is going to be mainly looking at variables, subjects over a course of time. Now, where or what kind of analysis techniques would we use for this? We could use autoregressive models. We could use moving averages. We can also use autoregressive intervals with moving averages. So that's kind of where the analysis might look like. So our second type of data is going to be cross-sectional data. Now, what is cross-sectional data? That is going to be looking at multiple subjects over, let's actually use multiple colors. Maybe that'll be easier to understand, right? So we've got Bob, we've got Joe, we've got his friend Liz, and we're going to be observing them over one period of time. Now, where might we see this data? We could see this in survey data over household income. So say they all live in one house, right? And we want to see what the difference is between their incomes in the year 2024. That's kind of what this data might look like. Now, a key feature of this is that whereas time series, it was really important that the time was kind of noted this over, a couple periods of time. This is going to be more the difference between each individual. So really, let's draw Bob, Joe, and Liz in again. And we would want to see the variance between each of these individuals. So this is what we're going to be looking at, right? That's what I was talking about whenever we see survey data with household income. We're looking at the variance between each individual. What kind of analysis techniques might we use for this? We could use ANOVAs. We could use t-tests for those that really like statistics. And then we could also use a regression analysis. And that's kind of the quick know-how for cross-sectional data. So now our third and final type of data that we're going to talk about today is panel data. What is panel data? It's going to be a mixture of our time series and our cross-sectional data that we just talked about. What I mean by that is we have Bob, we have Joe, and we have Liz, and we're going to be looking at them all over multiple time periods. So we're going to look at them from 4 o'clock, 6 o'clock, and 8 o'clock. And we are looking at each of those individuals at each of those times. So I'll draw kind of like a tree to symbolize what that means. So we have Joe at 4, Joe at 6, and Joe at 8. We have, Bob, sorry. Don't want to give them identity crises, right? Bob, we have Joe at 4, 6, and 8. And then we also are going to have Liz at 4, 6, and 8. So you can see kind of a tree of what this might look like. Here we have 3 data points all about Bob. Here we have 3 data points, but one is about Bob, one is Joe, and one is Liz. And now whenever we combine those to get panel data, we have 9 different data points. So where else might we see this in kind of a real world application? We would be able to see this in something like income or unemployment rates. We have our tie, right? Income or unemployment rates of a household over a period of time. So say 5 or 10 years. So we're looking at what Bob, Joe, and Liz's income was, or how many jobs they held over the course of 2014 to 2024. Now, what kind of analysis tools might we use for this? We could use difference in difference, so DID. We could use something like a fixed effects model, or we could use something like, let me actually write that, fixed effects model, or we could use something like a mixed effects model even. So that's kind of going to be the type of data and analysis techniques we would see for panel structure. And again, I know that can get a little confusing. Try and remember that it's a mixture of both time series and cross-sectional data in order to get panel data. So now we're going to talk about some key differences between each of our 3 data structures. And this should be sort of a high-level overview of what each of those structures look like with the dimension of variation, the applications, and the data structures. So for time series data, our dimension of variation is going to look kind of like a variation of maybe different time points, right, over one individual. In this case, it's just Bob. Now, our dimension of variation for cross-sectional is going to be a little different. That is going to look like a variation of people. So we've got Bob, we've got Joe, and we've got Liz. And that we're going to look at all 3 of these individuals over one time period, right? And then for panel, like we said earlier, it's going to be a mixture of both the time series and the cross-sectional. So this is going to be 3 individuals. We've got Bob, Joe, and Liz over our multiple different times, our 4 o'clock, 6 o'clock, and 8 o'clock. Remember that kind of tree graph that we drew earlier with the 9 different lines. That's what our panel dimension of variation is going to look like. Now, for applications, our time series is going to look kind of like maybe a trend or forecast, and then we have a break here, and then from here on, we're trying kind of forecasting what maybe the stock market or maybe the cost of gas might look like, right? For applications, we've got our 3 individuals. We've got Bob, Joe, and Liz. Oh, Liz is a little tiny here. And we're looking at the difference in variations between each of these individuals. And then for panel data, we are looking at sort of what they would look like are the changes over time. So this might be something like this graph, and we're looking at a point in 2022, 2023, and 2024. And we can look at Joe's income at those points. We can look at Bob's income, Joe's income, right? And then we can also look at Liz's income at those different time frames. Now, lastly, we have our data structures for time series, and that is going to look like snapshots of one person over multiple time periods. So we're looking at just Joe over 3 different times, but it's just about Joe. Whereas here, For cross-sectional data structures, it's going to be a little bit larger, and we're going to look at Joe. Oh, I keep saying Joe. I mean Bob. I'm giving them identity crises. Bob, Joe, and Liz, but we're looking at them all at one time. So it's just one single snapshot. And now here for panel, it's a little bit more convoluted. This is going to be 4 different snapshots for this example, right? And we have all of the individuals at each of the time frames. Now, I'm only going to draw 2 people because even that is a lot to draw, but I hope you get the point. So we're looking at multiple snapshots of multiple individuals over a course of time. Now, like I said, this is going to be our quick and dirty one kind of view of what the key differences between each of the 3 data structures are: our time series, cross-sectional, and panel data. I hope that made sense, and I hope you had fun watching me do all of this. Thank you for joining. If you enjoyed this video and want to see more like it, please like and subscribe. If you have any questions or want to share your thoughts about this topic, please leave a comment below.